Math 082, Practice Final Exam Review, Problem 72, Parts A, B, C, and D. Here in 72, we have a decimal multiplied by a power of 10. Multiplying by a power of 10 has the effect of moving the decimal either to the right or to the left. Because the exponent is positive, that's a signal to move the decimal to the right. 4 places. 1, 2, 3, 4. Therefore, we have 40564.3. In other words, 40,564.3, or 3/10. Let's check the answer key. Let's move on to Part B. In Part B, we must write this decimal in scientific notation. We will write it of the form some number times 10 to a power, where this number must be at least 1, but also less than 10. And the exponent is an integer, positive whole number, negative of a whole number, or 0. Putting the decimal between the first 7 and the 8, we create 7.87507. Now the question is, what should the exponent be? This decimal has been moved 2 places. Do I put positive 2 or negative 2? Well, whatever we put here, remember that this number is a signal to move this decimal. If I were to put negative 2, this number here, this power of 10 that's being multiplied, is a signal to this decimal to move to the left 2 places. And then what we have does not match the original. If we have times 10 to the positive second power, multiplication by this power of 10 with a positive exponent is a signal to move this decimal to the right 2 places, and that would return us to our original decimal number. So it is correct to have a positive power of 2 here. Another way to think about it, if your original number, here is 787.507, if it's at least 10, tens, hundreds, thousands, 10,000s, millions, and so on, this exponent here in scientific notation will be positive. We will multiply and then write the final answer in scientific notation. First of all, notice that despite the different symbols, the only operation involved here is multiplication. 7 times 10 to the 11th. This is multiplication. 8 times 10 to the negative 8. Since multiplication is the only operation, we can shift around the factors without affecting the overall value. Let's write 7 times 8 times 10 to the 11th times 10 to the negative 8. 7 times 8 is 56 times 10 to what power? When we are multiplying and the base is the same, the exponents are added, 11 plus negative 8. So we have 56 times 10 to the third power. Now what we have is not in scientific notation, because this number here is not between 1 and 10, at least 1, but strictly less than 10. 56 itself must be written in scientific notation. Let's put the decimal between the 5 and the 6 to create the number between 1 and 10, and then multiply by what power? If you remember what we said in the last problem, if the original number is at least 10, then the power of 10 in scientific notation is positive. Now we've moved the decimal only 1 place. In scientific notation, since this number is 10 or larger, the exponent here is positive. Also, this makes sense. 10 to the first power is 10. 5.6 times 10 is 56. Bring down the 10 to the third power. So we have 5.6 times 10 to what power? Again, since we have multiplication with the same base, 10 and 10, we add the exponents. So our final answer in scientific notation is 5.6 times 10 to the fourth power. Let's check that. Here we have Part D. We will divide 8 by 2 and get 4 times. In a division problem, and that's what this is 10 to the 5th divided by 10 to the negative 8, Because the base, 10, is the same for each exponential factor, we subtract the exponents. We take 5, we subtract, that's the property for division where exponents are involved, and what we subtract is negative 8. So we have 4 times 10 to what power? 5 minus negative 8 is equivalent to 5 plus 8, because subtraction of a negative fuses together into an addition symbol. 4 times 10 to the 13th, let's check that.